Everyone, this is section 3.1, quadratic functions. In this section, we're going to discuss the definition of a quadratic function, properties of a quadratic graph. We're going to talk about increasing and decreasing functions or parts of functions on a specific interval, finding the graph of a quadratic function, finding the equation of a quadratic function, and then calculating the vertex of a quadratic function or equation. We're going to start with some definitions as usual here. The first definition is standard form of a quadratic function. It's important in your notes that you write down that this is standard form because we're going to have another form in a little bit in this lesson. Standard form of a quadratic looks like this. ax squared plus bx plus c equals f of x, and that's if it's written in function notation, but remember that that also may look like a y. A, b, and c are all real numbers, and a cannot be 0, because if a is 0, we would not have an x squared term, and that's the biggest piece that makes it a quadratic function. So you're looking for your highest power to be a 2, so we say that this is a degree 2 polynomial. That's something we talked about in a previous lesson earlier in this semester, and again we call that in general a quadratic function in standard form. The quadratic functions will have a shape called a parabola, which are going to look like this or like this. So it's going to be a U shape, either opening up or opening down, and we'll talk about that a little bit more later. The vertex is the minimum or maximum point. So it's going to be right in the middle of your parabola, the point that's the highest point or the lowest point. The vertex, which we describe as HK, can be calculated if you have an equation in standard form using the following formula. To calculate h, we do negative b over 2a, or sometimes we like to say the opposite of b over 2a. So that b and a are coming from that standard form you see on the top. B is the number in front of the x, a is the number in front of the x squared. So the opposite of b over 2a will give you the h, which is really the x coordinate of your vertex. Now the second part of this formula looks a little complicated. This is how we calculate k. When we see f of negative b over 2a, remember that function notation when we see a parentheses tells us the number inside the parentheses is what we're plugging into the function. So really what that's telling us to do is plug h into the equation. So we do negative b over 2a to calculate h. We plug in h to get k, and that will calculate our vertex for us. And we'll practice that in a little bit so you can see what that looks like. We also have something called an axis of symmetry. An axis of symmetry is a vertical line that goes through the middle of our parabola, and it creates symmetry. That's where it gets its name from. So it's going to look something like this. It's not actually part of the graph, but again, it's the vertical line that cuts it in half. Because it cuts it in half, it's always going to go through the vertex, and because the vertex is calculated using the formula negative b over 2a, it's also the same formula we use to calculate the axis of symmetry. We put an x equals in front of it because it's always a vertical line, and that's the equation of vertical lines if you remember that from before. X equals is vertical, y equals is horizontal. A few more things that we can talk about here. There's two different cases, as I mentioned earlier, of parabolas. One that's opening up and another that's opening down. This textbook, instead of saying opens up, will use concave up. And instead of opens down, use concave down. What determines if a parabola opens up or down is the a value. If you have an a value in your equation that is greater than 0, which means positive essentially, your parabola will open up or concave up. That means the vertex will be at the bottom of your parabola, and therefore the vertex is a minimum. If you have an a value that is less than 0, or negative, that's what will cause the parabola to open down or concave down. That forces your vertex to be at the top of the parabola, and therefore in this case we say that the vertex is a maximum. The other thing that we can look at in terms of parabolas is where our function is increasing and where our function is decreasing. What I've got written on the bottom here are formal definitions for increasing and decreasing. But basically what these mean are an interval where the function is increasing or decreasing tells you that the graph, as you read it from left to right, and we're going to always read our graphs from left to right like we're reading a book. If the values are going up or the graph is increasing, we say that between those two x values, the graph is increasing overall. And if we're reading the graph from left to right and the values are going down, then we say that that portion of the graph is decreasing. So let me give you an example. Let's say my vertex was the point 2, 3 on this parabola. The left side of this parabola, as I go from left to right, is going down, and the right side of this parabola, as I go from left to right, is going up. So we would say that this parabola is decreasing on the left and increasing on the right. When we list those in notation, they're going to look very similar to the interval notation that we used before. You will always use parentheses, and you will always use x values, which is what this portion of the definition says. So for the graph above that I've got labeled here, it's decreasing from all the numbers smaller than 2 all the way up to 2. So we would say from all the x values negative infinity all the way to 2. And again, we're only using x values. So for the purposes of this question, the y value is irrelevant. Then it starts increasing. It turns around. It is increasing from 2, and then it increases forever as this graph goes to the right, so all the way to infinity. So you're going to notice when you list increasing and decreasing on a parabola, it's always going to be negative infinity to a number, and then that same number to infinity. That number truly is the h value, or the x coordinate, from your vertex. Now what could change is it might be increasing on the left and decreasing on the right. Depending on which way your parabola is opening or which way it's concaving, those two pieces may be flipped. And we'll again practice that a little bit more with some graphs in a moment. Okay, let's do an example. So here we have a parabola that's graphed already for us, and we have the equation. The first thing we want to do is name the vertex of the parabola. So remember, vertex is like the turning point, it's the middle of the parabola, the highest or the lowest value. So we can look at it and say, okay, we have obviously a low value here, and that point is what we're looking for. Here, because we have the graph, we can just name it. It is the point 1, -4. So we would say that 1 is the h and -4 is the k. In addition to that, if you didn't have this graph, you could use the equation to calculate that vertex. Remember our formula to get the x, or the h, was -b, or opposite of b, over 2a. In this equation, we say that a is 1, the number in front of the x squared is 1, the b is -2, and the c is -3, the numbers in front of the x and the constant respectively. And remember, if there's a minus in front of a number, it means that term is negative. So if we were going to use our vertex formula, the opposite of b, instead of a -2, would be a +2. Divided by 2 times a is 1. So now I have 2 over 2, which gives me 1. And you'll see that's the same x value we found from the graph. If you want to find the y value that goes with that, you plug 1 into the function. So that would look like 1 squared minus 2 times 1 minus 3, which gives you -4. So that's how we use that -b over 2a formula. And again, the -b over 2a is giving me the h part of my vertex, or the x coordinate. And when we plug that number in, it's giving me the k, or the y coordinate of my vertex. Next, we want to know if it's a minimum or a maximum. Because we already said that that vertex is a low point, we're going to say that it's a minimum. Then we want to know if the graph is concave up or concave down. You can see that this parabola is opening up. Think of it like a cup. I remember a cup opens up, so that is concave up. You could also look at your A value in the equation. A value is greater than 0. That tells us that it's concave up. It also tells us we have a minimum. So again, without the graph, we could still answer that question. Find the axis of symmetry. Axis of symmetry is always x equals negative b over 2a, which again, we already calculated that, x equals 1. So that means the vertical line, x equals 1, if I drew that in here, would create symmetry on my graph, meaning I could flip my graph over that line, reflect it over that line, and it would look exactly the same. Finally, here we want to list any intervals where the function is increasing or decreasing. So again, remember you want to read your graph from left to right. As I read this graph from left to right, you can see that it's going down on the left and then up on the right. So we're going to say that it is decreasing from negative infinity all the way up to the x coordinate of the vertex, 1. Then it turns around and starts going up, increasing from the x coordinate of the vertex all the way to infinity. And again, these are always parentheses. Sometimes people will want to put a bracket with these because we're used to that interval notation with domain and range, but increasing and decreasing intervals are always going to be parentheses. And again, always x values. Okay, let's do another example where we do not have the graph, we just have the equation. So here we have a function f of x. We want to determine whether the graph concaves up or down. We want to find the vertex. We want to determine if the function has a max or min. And then we want to find the axis of symmetry. I'm going to do these problems a little bit out of order. The first thing I'm going to do is just name my A, B, and C from this standard form. A is the number in front of the x squared, negative 4. B is the number in front of the x, 12. And C is the constant, 7. From the A value alone, we can answer some of these questions. If A is less than 0, or remember that just means negative, you can hopefully imagine in your head that our parabola is going to look something like this. From that picture alone, we could say that part A, it concaves down. And then part C, we could see that the vertex will be at the top. So we say that there is a maximum point on the graph. The next thing I would do in this problem is find the axis of symmetry. Negative b over 2a, or the opposite of b over 2a. The opposite of b is a negative 12. 2 times a, oops, almost wrote 4 there. Try that again. 2 times negative 4. So I have a negative 12 over a negative 8, which will give me positive 3/2, or you could just say 1.5 there. So my axis of symmetry, part D, is x equals 3/2. Again, remember that x equals is very important because it's always a vertical line. So that, again, is that line that's creating symmetry or an even reflection on my parabola. Finally, part C, I actually have the first part of this already. If I'm looking for my vertex, remember the first part of your vertex is that same h value, or negative b over 2a, that we found for the axis of symmetry. So all we need to do to get the y value that goes with it is plug the number we found into the function. So we're going to do negative 4 times 3/2 squared plus 12 times 3/2 plus 7. And then you can type that in the calculator. Again, you can use 1.5 if that makes it easier. And I get 16. So our vertex is 3/2, 16. If you want to check any of these answers, remember, you can just graph it in your calculator. And many of these things you can find using the graphing calculator or confirm using the graphing calculator. Now, we wouldn't be able to see 16 on our standard home screen, but remember you can hit Window and you can change the values in there. So you could change the Y max in your window menu in your calculator to like 20, for example. And then that would give you a nice clear picture in the calculator of what this parabola looks like. And you could see if 1.5 16 truly is the maximum point on that graph. Okay, here's a problem for you to try on your own. All right, let's start with naming our A, B, and C values. A is 3, B is -6, and C is -7. Because the A value is greater than 0, a positive number, we can say that the graph concaves up, and therefore draw that little shape there. The vertex would be a low point, so it is a minimum. The next thing I'm going to calculate is -b over 2a. And that's going to help me with my vertex and axis of symmetry. So -b, or the opposite of b, would be +6. 2 times a, 2 times 3, 6 over 6, and you get 1. So the axis of symmetry is x equals 1. To take it a step further, to find the y that goes with that, you can plug 1 into the function, and this is function g, so we'll say g of 1. 3 times 1 squared minus 6 times 1 minus 7. And that's going to give me 3 minus 6 minus 7 will give me -10. So my vertex is the point, and again here it's a low point on the graph, minimum 1, -10. So let's take that sketch we had a second ago and make it a little bit better. We know we're going up, we know there's a minimum, and we know what that minimum is now. It's the point 1, -10. So we can use that to help us figure out where we're increasing or decreasing. As we read this graph from left to right, it is decreasing on the left and increasing on the right. So we would say that it is decreasing from -infinity to 1, and then increasing from that x value 1 to infinity. Remember, for the purposes of this, increasing and decreasing, you only need x values, so that y value of -10 should not pop up anywhere in those intervals. Okay, let's look at the second form that a quadratic equation could be in. This is called vertex form, and hopefully that'll be obvious where it got its name from in a minute here. The vertex, again, can be labeled as hk, and now look at the form we have. F of x equals a, that's the same a we were referring to in the other equation, that number that will eventually be in front of the x squared. And now you can see that h and k are actually showing up in the formula. We don't have a b and a c anymore. What's nice about this form of the equation is if we can write a quadratic in this form, we can easily see the vertex. And if we can easily see the vertex, it's one less calculation you have to do. It's also going to make it a lot easier to get the graph later because the vertex is the most important point on the graph. It's where it turns around, or the highest or the lowest value. The one thing you have to be careful about in this form of an equation is there is a minus built into the equation. So if you were going to, from an equation, name the vertex, that minus means your h value is actually the opposite of what you see in the equation. So for example, if I had an x minus 4 in the equation, my h value would be +4. Or if I had x plus 5 on the inside there, my h value would be -5. So that negative just tells us use the opposite sign for h. So let's look at an example here. We have the function f of x equals 3 times the quantity x minus 2 squared. Again, that squared here is telling me that if you were to FOIL this out, for example, your highest power or your degree would be 2, and that's what makes it a quadratic. Minus 5. We want to determine if there is a concave up or concave down for this parabola. We want to determine if there's a min or a max, vertex, axis of symmetry, and increasing or decreasing. So again, a lot of the same things that we have answered previously already, just with the other form. We're going to start by naming our important pieces. This time, instead of an A, B, C, it's an A, an H, and a K. A, the number in front of the parentheses, is 3. Be careful with H. Remember, H is the opposite of the sign that you see inside the parentheses, so it's a positive 2. And then K is the number that's outside the parentheses, so in this case, a negative 5. The A value will again help you with parts A and C here. Our A value, 3, is greater than 0, or positive. So that means if I were to sketch this parabola, it would look something like this. We say that this is concave up, and then the vertex would be at the bottom, so we say that there is a minimum. Next, find the vertex. So in the last few problems, this involved a little bit of calculation, but remember, vertex is just H and K. And we have H and K. 2, negative 5. Done. I can label that here. 2, negative 5. Axis of symmetry, remember that's always x equals, and it always goes through my vertex, so it's x equals the x coordinate of my vertex, which again we already know is 2. So for these, you can always say x equals h will always be the x coordinate, will always be the axis of symmetry. And then finally, we want to determine if these intervals are increasing or decreasing and where. So again, we're going to read this graph from left to right. As I go from left to right, it decreases first and it increases second. So we say that it is decreasing from negative infinity to the x coordinate of the vertex, 2, and then it is increasing from the x coordinate of the vertex, 2, all the way to infinity. Let's do another example with this form. Here we want to find the vertex form of the quadratic function f, whose graph has a vertex at 1, negative 5, and passes through the point 3, 7. Then, after we have our equation, we want to know if this has a minimum or a maximum value. Because it says to find the vertex form, I'm just going to go ahead and write down that form again. F of x, or y, equals a x minus h squared plus k. The next thing I know is I know the vertex, which, remember, vertex here is 1, negative 5, is also h and k. So we can fill those values into our equation. F of x equals a x minus my h value, 1. Oh, that looks like a decimal. Let me get rid of that little extra dot there. There we go. So x minus h, x minus 1 here, plus my k value, so I can say plus negative 5 or just minus 5. Now you'll see I've got variables. Remember, f of x means y. X, of course, is a variable. A is a constant. A, we need to have a number there. So we still have to solve for A to have a complete equation. And that's where this other point comes in handy. So if you think back to what we did with lines, once we got to a point where we wanted to solve, for example, like the y-intercept, we could plug a point in for x and y and use that to help us solve for the missing number. So we're going to do the same thing here. Again, you can think of that f of x like a y. So I have a y value of 7, and I have an x value of 3. You can see now that a is the only variable left, so we're going to solve for it. 3 minus 1 squared, order of operations tells me that parentheses and the power. 3 minus 1 is 2. Squared gives me 4. A minus 5. From there, I'm going to add 5 to both sides, so that's going to give me 12 equals 4a. And then I'm going to divide by 4 on both sides, which gives me a is 3. So my final answer here will be f of x equals, fill in my a, 3, x minus, fill in my h, 1, fill in my k, minus 5. Now remember, at the top it also did ask, does it have a minimum or a maximum? And all you need for that question is the a value. Here, a value is positive or greater than 0. So we can imagine our parabola is going to concave up or open up. That means the vertex is at the bottom. So we can say that this graph would have a minimum value. And the minimum point is just that vertex, 1, -5. The next thing we need to discuss now that we know both forms is how to convert between the forms. The first way that we can convert is from vertex form to standard form. So vertex form again is the one with the parentheses, and we're trying to get it to standard form, which is the one that had the A, B, and C, no parentheses. Here are your 3 steps. Step 1, we're going to FOIL. And I'm going to do these one at a time with the problem at the bottom here. When we're foiling, that shows up when you have a parentheses times itself, or parentheses squared. So remember, you can always write that parentheses twice. That's what that power of 2 means. And now we are foiling those 2 parentheses together. So I'm going to say FOIL. I'm going to bring down my -2. I'm going to keep a parentheses there because that -2 is going to apply to everything inside. My first terms, x and x squared. My outside terms are a -4x. My inside terms a -4x. My last terms, -4, -4, +16. Bring down the 5. Next step, we distribute. That's that -2 in front. We're going to distribute -2 into everything in the parentheses. That will be a -2x squared, a +8x, a +8x, a -32, plus 5. And then finally, we combine like terms. So my final answer will be -2x squared, 8x and 8x give me 16x, and then -32 plus 5 will give me -27. And again, that's what we're looking for standard form. A number in front of the x squared, a number in front of the x, and then a constant, a number by itself. So that's our A, B, and C respectively, -2, 16, and -27. If you want to check this, it's very easy to do with the graphing calculator. You can just graph your original equation and your new equation using the y equals menu. So you're going to have to use 2 of the equations. I would just use y1 and y2. You would graph, again, the original equation that you started with. You guys can try this on your calculator now if you want. You're going to graph your answer. And if you've done it correctly, they should be exactly the same. It should be one parabola on top of each other. Because all we did here was change the form of the equation. We shouldn't have changed the equation itself if we've done it correctly. So you should get the same graph both times. And again, if you don't get the graph the same both times, then you know to go back and check your work. The other way that we can convert is from standard form, remember that's the one with the A, B, and C, no parentheses, to vertex form. That's the one with the H and K. The first step to convert this way is to calculate that H using the -b over 2a. So again, we're going to go through one step at a time in this problem at the bottom. The first thing I'm going to start with is naming my A, B, and C. Here my A is 2, my B is -8, my C is 3. So if I want to calculate -b over 2a, the opposite of b is +8, 2 times 2 at the bottom. It gives me 8 over 4, which is 2. So your h value is 2. Second step, calculate k by evaluating h in the function. So again, this is what we were doing before to find the second part of our vertex. We just plug the first number we get, 2, into the equation. 2 times 2 squared minus 8 times 2 plus 3. So that's going to give me 8 minus 16 will be -8 plus 3 is -5. And again, that's the second half of your vertex. or your k value. Finally, fill in your equation. So I'm going to write down what that vertex form was again. It was a x minus h squared plus k. Fill in my a, and that's the same a as the standard form, 2. X minus my h value is 2. And then plus my k, so plus -5, or I can just say -5. Again, you check this problem the same way you check the other one. You can graph the original equation in your calculator. You can graph your answer in the calculator, and you can easily see that they would be the same parabola, therefore they are the same function, so you converted correctly. Okay, here are a couple vertex form problems for you to practice on your own. All right, for problem number 1, again, we have the vertex. So remember that's the h and k. So I can start by filling that into my function. A, I don't know. X minus my h, so here it would be a minus -3 or a plus 3 squared plus k. Then you have your point. Remember that's an x and a y. Not our vertex, but some point on the graph. We can plug that in. 7 is the y, 1 is the x. Now the only variable left is a, so you can solve for a. 1 plus 3 squared, that's 4 squared, or 16. So we're going to get 16a plus 5. Subtract 5, that gives me 2 equals 16a. And then divide by 16. You should have gotten a is 2 over 16, or that reduces to 1/8, or if you had 0.125, that would be the same thing. So the final answer here is the function f of x equals, fill in my a, 1/8, fill in my h, which was a -3, so it's going to look like a plus in your equation. Remember, those are always opposite, plus k. In the next problem, we're trying to convert to vertex form. So the first thing that you should have done is name your a, your b, and your c. Here our a is 4, our b is -6, and our c is 3. We're going to calculate -b over 2a, or the opposite of b over 2a. The opposite of b is +6. 2 times a, 2 times 4. So I have 6 over 8, which is 3/4, or if you had 0.75, that's fine. That's our h. To get the k that goes with it, we plug h, or the x-coordinate of my vertex, into the formula. So we're going to do 4 times 3/4 squared minus 6 times 3/4 plus 3. And again, you can use your calculator here. If it's easier again with the 0.75, go ahead and use that. And I get 0.75 in my calculator, or again, you can say 3/4, and that is your k value. So now our function, instead of standard form in vertex form, is a, which we said was 4, x minus my h, 3/4, plus my k, 3/4. And that's your final answer. The next two problems that we're going to do are graphing quadratics by hand. This is without our calculator, but of course you can use your calculator to check this. The first thing we're going to do is identify the important coefficients. So depending on what form you're in, that's either going to be a, b, and c, or a, h, and k. Second, you're going to determine how the parabola opens, up or down. We're going to find vertex and axis of symmetry using a formula if necessary. Then we're going to find 2 other points. You want one to the left and one to the right of your vertex. And then from there, once we have 3 points, we'll be able to sketch our function. So let's start with this equation. You can see that there are no parentheses here, so this is standard form. And again, I'm going to start by naming my A, number in front of the x squared, 3, my B, number in front of the x, -3, and my C, the constant, -6. In the second step, we're going to determine which way this opens. Because A is a positive number, we say that it opens up, or it's concave up. And that also tells us, if you picture a parabola opening up, a cup opening up, you have a point at the bottom, so we could also say it's a minimum. Third step, we're going to calculate the vertex. If you're in standard form, you need to do -b over 2a. Opposite of b here is +3. 2 times a, 2 times 3. That's going to give me 3 over 6, or 1/2. To get the y value that goes with it, we're just going to plug that number into the function. 3 times 1/2 squared minus 3 times 1/2 minus 6. And again, you can type that in your calculator at this point. And it gives me -6.75. So we say that the vertex is 1/2 -6.75, or if you want to say 0.5, -6.75, that's fine. We can also say that the axis of symmetry is x equals what we got for the x coordinate, in this case 1/2. So I'm going to go ahead and graph that. 1/2, I'm at -6.75. And again, we remember this is also a minimum on the graph, and we know our graph is going to open up, so we could almost make a sketch of this right now. We know that that's going to be the bottom of the parabola, and we're going to have a U that's upright when we graph this. In the next step, we're going to find 2 other points. So think of this like we have an XY table, and we already have one point in the middle. In the middle, we know we have 1/2 -6.75. What we want to get is a number that's smaller and a number that's larger for x, so that way we have a number to the left and a number to the right. You can pick easy numbers to plug in, like 0 is really easy to plug in, 1 is really easy to plug in. You can plug in values that are further away if you want, like -3 and +3 or something like that. If you plug 0 into the equation, 3 times 0 squared minus 3 times 0 minus 6, you will get -6. If you plug 1 into the equation, let me erase what I had there a second ago. And again, you can use your calculator at any point in time if you are stuck here. 3 times 1 squared minus 3 times 1 minus 6 will also give me -6. So I've already got this point graphed. Let's graph the other two. 0, -6 is on the left side. It was smaller. 1, -6 is on the right side. It was bigger. And then from there, we can sketch. Try to create a smooth curve when you graph these. Oops. And it's going to look something like that. Sorry, that one's a little wobbly. The last thing that it said to do, which potentially you might be asked to do in my math lab, is estimate the x-intercepts. The x-intercepts, remember, are sometimes considered solutions, or zeros were other words that we saw for those, and that's approximately where it's crossing the x-axis. And if you wanted to get a better picture of this, of course your graphing calculator would give you a more accurate depiction, but we're going to estimate the best we can here. So I would say that the first x-intercept is somewhere between -2 and -1, so I'm maybe going to say -1.5. And the other one is somewhere between 2 and 3, so I'm going to say maybe about 2.5. Again, those are not exact. That's just an approximation off of this graph. You can always calculate these using your calculator. If you use that trace menu, if you hit second, calculate, and then choose 0. Remember, we did that in a previous section when we wanted to solve using zeros or solve using that method, that's also an option to actually calculate them. But again, for now, an estimation is plenty. So let's go back and make sure I got everything. Coefficients, how it opens, vertex and axis symmetry, 2 other points, sketch. Oh, I guess I did a little extra with estimating the x-intercepts, that's fine. You could also estimate y-intercepts here. Actually, you don't even have to estimate them. We calculated it. Remember, a y-intercept is when x equals 0. So you have a point on your y-axis at -6, but you can't always calculate that one by plugging 0 in. Let's do one more with vertex form. And again, at the bottom here, we're going to find those x-intercepts in a minute. The first thing we're going to do is name those important coefficients. A, and because it's vertex form with the parentheses here, it's not a B and a C, it's an H and a K. A, the number in front of the parentheses, is -2. Okay, let's look at another graphing problem. Again, we're going to start in this problem by naming the important coefficients, and you can see that this is in vertex form. We've got those parentheses, that's that big clue. So this time we're going to name A, H, and K. A, the number in front of the parentheses, is -2. H, the number inside the parentheses, remember it's going to be opposite of the sign that you see there because it's technically a minus. So there's really a -1 in there. That x plus 1 is really hiding an x minus -1. So you want to make sure, again, you always use the opposite sign for that H from what you see in the equation. K, the number on the outside, 3. Second thing we're going to do is name which way this opens. My A here, again, will tell me that information. My A is negative, less than 0. So that tells me it is concave down. And again, if you can imagine a parabola opening down, that also tells me I have a maximum value on the graph. Third, my vertex, which here, this form, it's going to be a little bit easier. It's your H and K, so -1 and 3. And your axis of symmetry is x equals the x coordinate of your vertex, -1. The next thing we're going to do is we're going to go ahead and graph that vertex, -1, +3, and remember that's the top, the maximum, so we can almost get a little picture of this, what that's going to look like. The only thing we need now is really we got to figure out how wide this is. It could be really fat parabola or really skinny parabola. So to figure that out, we're going to put the vertex in the middle of an XY table and just pick points on either side of -1 in this case. So I'm going to pick 0 on one side and -2 on the other. And then I'm going to plug those into the equation. If I plug in 0, oops, ignore that, 0 plus 1 squared plus 3. -2 times 0 plus 1 squared, which is 1, gives me -2, plus 3 gives me a +1. And then if you plug in -2, -2 plus 1 is -1 squared, times, which is +1, times -2 is -2, plus 3 gives me 1. And you'll notice if you choose correct variable or values on either side that are the same distance from your vertex, you'll notice you'll get this symmetry. You hopefully saw that in the last problem as well. We're getting that same number out twice because parabolas are symmetric around the vertex. We get the same values out if we pick x's that are the same distance from the vertex. So it's a nice way to check that you're doing it right, that you get that same y value twice. But again, you have to pick x values that are the same distance from the vertex to see that happen. From there, I'm going to create my parabola, smooth curve, arrows on both sides to show that it's going to go down forever. Estimate the x-intercepts. So again, that's approximately where it's crossing the x-axis. So there and there. I'm going to say approximately -2.1 and maybe +0.1, something like that. Or again, the x values where it's crossing. Y-intercept, we actually have this in our table as well. or you can see it on the graph where it's touching the y-axis. 1. The other thing we haven't done in any of these problems yet is name domain and range, so maybe we'll just practice one of those. Domain is all of our x values from left to right. There are no restrictions in this equation. There's no denominators, no square roots, and you can see that this graph will go forever to the left and right as it curves down. So my domain is all real numbers. And that's going to be the same for all quadratics, because you will not have any domain restrictions in a degree 2 function. Your range, this graph does not go up and down forever. It goes down forever, but it only goes up to the highest y value, which is at 3, where your vertex is. So we're going to say our range is negative infinity all the way up to 3 with a bracket. The last couple problems that we're going to do in this lesson are some application problems of quadratics. You're probably going to need a calculator for a couple of these. Here we have, from the top of a building, a projectile is shot 400 feet high with a velocity of 64 feet per second. The altitude h after t seconds is given by the following function, and you can see that this is a quadratic in standard form because we have a number in front of our x squared, a number in front of our x, and a constant. But again, that squared power of 2, degree 2, tells us that we have a quadratic function. Here we want to find the maximum height of the projectile. If you are ever in a quadratic problem asked for a maximum or minimum, that's a fancy way of saying you need to know the vertex. So we're going to start by calculating our vertex here. We're going to name our A, negative 16, B, 64, C, 400. And if you get to any questions on my math lab that don't have an A, B, or C, you just use a value of 0. To calculate the vertex, we know we're going to do negative b, or opposite b, over 2a. The opposite of b is negative 64. 2 times a is negative 16. So that's negative 64 over negative 32, which is positive 2. That is the x coordinate of your vertex, or in this case, the t value. You can see that's our variable in place of the x. To find the second part of my vertex, we're going to evaluate for 2 into the function, and this is function h, where h stands for height. So it's going to be negative 16 times 2 squared plus 64 times 2 plus 400. And then that you can just type in your calculator, negative 16 times 4 plus 64 times 2 plus 400. And you're going to get 464. So my vertex is the point 2, 400, and, I said 464 and I wrote 462 for some reason. That's strange. 464. So now to answer the question, what is the maximum height? So there's 2 parts to this vertex. 2 was your t, and 464 was your h. So that means after 2 seconds, 464 will be the maximum height. So not only does it tell you the height, that it's the maximum, it tells you when that will occur in the function. Next, we want to approximate when it hits the ground. So when something hits the ground, that means that the height is equal to 0. So in this function, it would be 0 equals negative 16t squared plus 64t plus 400. And because we're just approximating here, this is something that we could do in the graphing calculator. You could just type this equation in y equals, and when you have a y value equal to 0, you're actually calculating an x-intercept. So I don't have my calculator pulled up, but I'm going to do it to the side here and give you a rough little sketch. So in your calculator in y equals, you can type in negative 16x squared plus 64 times x plus 400. And you can just graph that in the standard window. You can always change it if you need to. And I'll show you the picture that I get in my calculator just in the standard window. Here's my graphing calculator screen. And then, get a different color here. I see, here's my tick marks. I see a line going like this. And then I have another line, boom, 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 doing that. So you can see it's a parabola opening down. I don't have to see the top of it here. Just to see the x-axis is sufficient because we're finding an x-intercept. Notice that we have two x-intercepts in this picture, here and here. The one that's negative represents a negative time, and that doesn't make sense in this situation. So although it's an x-intercept or a solution, because we're talking about this real-life situation, that one is irrelevant. If you look in your calculator for the positive place where we're touching the x-axis, you can just count the tick marks. 1, 2, 3, 4, 5, 6, 7, somewhere between 7 and 8. So I'm going to say approximately 7.5. And remember, instead of an x, it's a t here, so it represents seconds. So approximately after this object has been in the air for 7.5 seconds, it will hit the ground. And if you wanted a better estimate than that, you could always in your calculator hit second, calculate, and then calculate the 0. And you could use a left bound and right bound of 7 and 8 because we know it's falling between 7 and 8 on that axis. Here is one more application problem, and this is for you to try. Okay, so here the profit for a certain brand of MP3 player is described by the function p of x equals 40x minus 3000 minus 0.01x squared, where x is the number of MP3 players produced and sold. So hopefully this one didn't trip you up too much. You're a little out of order here. Your a is, again, the number in front of the x squared, so negative 0.01. Your b is the number in front of the x, 40, and your c is the constant, the number that does not have a variable, so negative 3000. We want to maximize the profit again. So as soon as we see that word, we're thinking vertex. Opposite of b over 2a. Opposite of b is negative 40. 2 times a is negative 0.01. So I have negative 40 over negative 0.02. And then you can calculate that in your calculator. And you're going to get 2,000. From there, you can evaluate 2,000 in the function to get the second half of your vertex. So 40 times 2,000 minus 3,000 minus 0.01 times 2,000 squared. And again, you should have typed that in your calculator. And we get 37,000. So your vertex is 2,000, 37,000. Now let's look back at what that represents. So it tells us here that x is the number of MP3 players produced and sold, and the function calculates the profit. So that's like your y. So 2,000 is the number of MP3 players, and 37,000 is the profit that will be received for that number of MP3 players. So to answer part A, how many MP3 players must be produced and sold? The answer to that is 2,000. Part B, what is the maximum profit? That's the second half of our vertex, 37,000.